And here's the Integrated 3 Semester 2 Final Exam Review. So first we're going to describe the transformation in terms of finding AH and K. A is the negative 1/4, and that is going to compress and flip the equation. H horizontal is -2. We're going to go left, and K is -3. So a graph of that would be having its reference point at -2, -3. That reference point is the point of inflection where increase goes to concavity changes. It would also be flipped in the sense that it would be coming from up to down. So you got, and it's compressed, so it doesn't go up or down very fast compared to the regular cubic. So something like that. How to do it? B, a cubic function is given. Write the specific equation for f of x. So what we don't have here is a. We could use one of these points to solve for it. Like for example, this point 1, 1. We also know h and k, by the way. H is here and k is here. So I know the equation kind of looks like, and I'm going to use y instead of f of x, a x minus 0 for h cubed plus k is -2. If I use this point 1, 1 in that equation, 1 equals a times 1 cubed minus 2. I'll add 2 to both sides, and that will give me 3 on the left equals a. So when I write my equation, 3 times, well, I don't really need the parentheses, but let me take those off. X to the third minus 2. Since there's no horizontal, I don't have to have parentheses around x minus h. Now, a quick way to get the a value also would be to count how far from here to here. 1, 2, 3, and over 1. So there's your 3. Okay, next we've got, given the graph, state some of the key features. So if we use that idea again, if we go from 2 to 6, then the a is 4. The h and the k are contained right here. H is 1. And then, there's a little typo here I just noticed. Right there, that shouldn't have an a. So actually it's -4 because it also flipped. And k is 2. Now, as far as the cubic goes, domain and range are all real numbers. So written like this, it means all real numbers or spelled out in words. The end behavior is that as x goes to positive infinity, the function goes down to negative infinity. As x goes to negative infinity, h of x goes up to positive infinity. Okay, then we got some multiplying and adding together, adding with like terms. So let's go with nice blue here. So 5x squared is the only x squared. Then you have minus 3x and minus 2x for a -5x. And a -12 with a -4 would be a -16. And we're done. With subtraction, you're going to have to distribute the negative over here. So if you want to keep track, this would be plus 2x cubed minus 7x plus 6x to the fourth and plus 8. Okay, looking through from the highest power, I see 6x to the fourth and also another 6x to the fourth. So 12x to the fourth. For x to the cube, I see negative 9x to the x cubed and positive 2x cubed for a negative 7x cubed. I don't see any x squares. For x's, on top I see negative x. On bottom I see negative 7x for a negative 8x total. And for the numbers, 15 plus 8, 23. And there you go. Okay, here's a little binomial squared action. If you know the formula is x squared minus 2ab, no, sorry, let's do this the right way. The formula is a squared minus 2ab plus b squared, where a and b are x and negative 9. So this would be x squared minus 18x plus 81. Now that's one way to do it. Fastest, most efficient. Another way to do it is to draw your box. Put x minus 9, do x squared minus 9x plus 81. Take every term out of the box and you have our answer. Now, when you have a multiplication like this, you definitely want to set up a box. It's just too many multiplications here. 5x squared minus 3x plus 10, negative 2x and plus 4. And then we just multiply until we're all done multiplying. So we got, let's change to black here. How about negative 10x cubed? How about 6x squared and negative 20x? Okay, in the second row, 20x squared, 5 times 4, negative 12x, and 40. So final answer, negative 10x cubed. Then you have 20 and 6, 26x squared, negative 32x, and finally 40. So that's page 1. Page 2. Factor the following. Okay, first thing I see is there's some greatest common factor here. There's a number that will divide into 8, 44, and 48 evenly, and it's not 8, it's 4. So 4, and then also for x to the fourth, x to the third, and x squared goes into all of those. So now we just use division to figure out what's inside of here. So 8 divided by 4 is 2. X to the fourth divided by x squared is x squared. Negative 44 divided by 4 is negative 11. And that would be x to the third divided by x squared is x. And 48 divided by 4 is 12. And x squared is already there. So can that thing be factored? Is it even factorable? Well, there's a quick way to check. If you do b squared minus 4ac, okay, where a is the 2, b is the negative 11, and c is the 12. So negative 11 squared minus 4 times 2 times 12. Negative 11 squared is 121, and 4 times 2 times 12 is 96. Subtract those two. 121 minus 96, you get 25. Okay, now 25 is a perfect square. So that means this is factorable. So we're going to have to use a little bit of the x here. So we'll take the first number times the last number, put that on top. So 24 on top and negative 11 on the bottom. We're looking for two numbers that will multiply to 24 and add to negative 11, and that would be negative 8 and negative 3. So if you do this the snowflake method, that's one thing, but I'm going to do this the factor by grouping method, which says this is how you split up 11x, or negative 11x. So you're going to go 2x squared minus 8x minus 3x plus 12. Then you look at them two at a time. Factor out the greatest common factor of each pair. So from these two, it's 2x, x minus 4, and from these two, negative 3 and x minus 4. Now, we needed to get x minus 4 the same in both of them, so now that can come out to the front, x minus 4, and then you got 2x minus 3. Now, don't forget, when you look for your final answer, we had already factored out 4x squared. So that needs to be part of your answer out in the front here. And there is our factorization. Okay, so for part B, we can also do factor by grouping. Look at them two at a time. X squared and x plus 7. And negative 9 and x plus 7. So we got it. We got the x plus 7 twice. So I can factor it out once. Gives me x squared minus 9. However, x squared minus 9 is factorable to x plus 3 and x minus 3. So there's my complete factorization. Now we use synthetic division or long division to rewrite this. We'll use synthetic. So if it says x plus 4 is the divisor, you're going to use negative 4. And now our coefficients, 1, 7, 11, negative 7, and negative 12. Let's see what we get. First, drop the 1, then multiply times negative 4, then add. Multiply times negative 4, then add. Multiply, then add. Multiply, then add. So no remainder. That means that the original equation has turned into x to the third plus 3x squared minus x minus 3. Okay, next side. Find all the roots given that f of 1 is 0. So that's telling you 1 is a root. Try it. 1, and you'll have 1, negative 3, negative 14, 48, and negative 32. So we expect a remainder of 0 here. So we got 1, negative 2, negative 16, 32, and 32, and 0. So look what we have left. X to the third minus 2x squared minus 16x plus 32. Well, let's see if we can do factor by grouping on that polynomial. So factor by grouping, x squared, leave behind x minus 2, and minus 16, leave behind x minus 2. So our common factor is x minus 2. Gives you x squared minus 16. Okay, so now we're solving, right? So finding all the roots. We can set this equal to 0. That means x minus 2 is going to be 2 as a root. And x squared minus 16 is going to give you 4 and negative 4. So our four answers are 1, the original one given to us, 2, 4, and negative 4. Giving the following graphs, state the following key features and behavior. Well, it's going up. It's going up. As you go to positive infinity, as you go to the right, you're going up. As you go to negative infinity, you're going up. The roots are going to be negative 1 and 3 and 4. Negative 1 is a triple root because it goes through this point of inflection right here. Then positive 3 is a single root, but 4, because it bounces, is a double. So 3 and 4, double. The y-intercept is right here at 0, negative 48. The domain is anything, all real numbers. The range, it goes as low as 150 and as high as infinity. And since it can get to 150, we're going to use a closed bracket on the left side and infinity to the right. Okay, next page. Let's do some trig. Okay, identify the following trig ratios of the angle. Here's the angle right here. Okay, the sine would be 24 over 8 root 10. But if I rationalize that by multiplying top and bottom by root 10, that gives me 24 root 10 over 8 times 10. The root 10 will turn into a regular 10. That'll give me 80. And then I can reduce 24 over 80, 3/10. So 3 root 10 over 10. The cosine is 8 over 24. The tangent is, oh, sorry, that's not right. Let's go back. Cosine is 8 over 8 root 10. Okay, the 8's cancel. 1 over root 10. If I multiply top and bottom by root 10, I get root 10 over 10. The tangent is 24 over 8. Or just 3. Now, the cosecant, the secant, and the cotangent, an easy way to remember is that the cos never go together. So cosine does not go with cosecant. It goes with secant. Sine goes with cosecant. And tangent goes with cotangent. The 3 at the bottom are just reciprocals of the ones at the top. So cosecant is the reciprocal of sine. And if you wanted to take that back to 8 root 10 over 24, that will reduce to root 10 over 3. Make that 3 a little better. The secant is the reciprocal of cosine. So you can go back to 1 over root 10 and just call it root 10. And the cotangent is the reciprocal of 3, and that's 1/3. Number 8. find all missing sides and angles. Okay, I get this third side here, AB, is the hypotenuse. So if I square it, it's equal to 10 squared plus 6 squared. That's 100 plus 36. I do not think that that's a perfect square. So we're going to have to do a decimal approximation here on root 136. And the square root of 136 is 11.7. Okay, now angle A. Angle A is the inverse tangent. The measure of angle A is the inverse tangent of 10 over 6. Make sure your calculator is in degrees mode when you do this. Inverse tangent, 10 divided by 6. 59 degrees, 59.0. It didn't ask you for the measure of angle B, but it should have. That would just be 90 minus 59. That would be 31 degrees. Oh, there it is, 31 degrees. And 11.7. All right, moral of the story, just scroll down. Okay, look at this box. Which pairs of measurements represent the same angle measure? They are coterminal angles. Show all work below. Which pairs represent the same angles? So that means you're going to have to convert. And the conversion between radians, so radians, 2 degrees, is pi over 180. So if I put, for example, if I want to go degrees to radians, I put R here, I put 20 here, and pi over 180. So then I cross multiply and divide, and 20 divided by 180 reduces to 1/9. So this is pi over 9. That is not 20 degrees equals pi over 9. Okay, and it would be very similar for any of these other ones. So let's say I did 225. So if I put 225 in place of D, then I'd be reducing 225 over 180. And that is 1 1/4 or 5/4. So yeah, this one does work because 225 equals 5 pi over 4. And then the last one, if I think of the unit circle, if I go negative 90, that's here. But if I count with pi over 2's, this is pi over 2, this is pi, this is 3 pi over 2. So yes, they are the same by the unit circle. Okay, the bell's going to ring here in about 2 minutes, and I'll have to attach the rest of this later. I got one more page to go. Find the exact value of the cosine of negative 2 pi. So here we go. 1 pi, 2 pi. Cosine is the x-coordinate on the unit circle. And the x-coordinate here is 1. That's just a 1. Negative 120. Okay, negative 90, negative 120. That means there's a 60-degree angle here, and a 90 would be here. Remember, 1, 2, square root of 3. The 2 goes on the hypotenuse. The square root of 3 goes opposite the 60, and the 1 goes opposite the 30. Now, find the sine. Opposite, square root of 3, over hypotenuse 2. Square root of 3 over 2. All right. We'll get this last part going pretty soon, and then we'll have all the answers. We'll see you next time.